Let's get started with our linear algebra review. In this video, I want to tell you what are matrices and what are vectors. A matrix is a rectangular array of numbers written between square brackets. So for example, here is a matrix. I'm going to write a left square bracket and then write in a bunch of numbers. And these could be features for a machine learning problem, or it could be data from somewhere else. But for example, the specific values don't matter. And then I'm going to close it with another right bracket on the right. And so that's one matrix. And here's another example of a matrix. Let's write 1, 2, 3, 4, 5, 6. So a matrix is just another way for saying is a 2D or a two-dimensional array. And the other piece of terminology we need is that the dimension of a matrix is going to be written as the number of rows times the number of columns in the matrix. So concretely, this example on the left, this has 1, 2, 3, 4 rows, and it has 2 columns. And so this example on the left, I'm going to say this is a 4 by 2 matrix, okay? Because it's number of rows by number of columns, so 4 rows, 2 columns. This one on the right, this matrix has 2 rows. So that's the first row, that's the second row, and it has 3 columns, right? That's the first column, that's the second column, that's the third column. So this second matrix, we say it is a 2 by 3 matrix, or we say that the dimension of this matrix is 2 by 3. And sometimes you also see this written out as, in the case of the left, you see this written out as R4 by 2. Or concretely, what people will sometimes say is that this matrix is an element of the set R4 by 2. So this thing here, this just means a set of all matrices that are of dimension 4 by 2. And this thing on the right, sometimes this is written out as a matrix that's an R2 by 3. So if you ever see, 2 by 3. So if you ever see something like this, R4 by 2 or R2 by 3, people are just referring to matrices of a specific dimension. Next, let's talk about how to refer to specific elements of the matrix. And by matrix elements, or elements of the matrix, I just mean the entries or the numbers inside the matrix. So in the standard notation, if A is this matrix here, then A subscript ij is going to refer to the I comma j entry, meaning the entry in the matrix is in the ith row and the jth column. So for example, A11 is going to refer to the entry in the first row and the first column. So that's the first row and the first column. And so, A11 is going to be equal to 1402. Another example, A12 is going to refer to the entry in the first row and the second column. And so A12 is going to be equal to 191. Just a couple more quick examples. Let's see. Let's say A32 is going to refer to the entry in the third row and the second column, right? Because that's 3, 2. So that's equal to 1, 4, 3, 7. And finally, A41 is going to refer to, this one, right? Fourth row, first column is equal to 147. And if, hopefully you won't, but if you were to write, say, what is A43? Well, that refers to the fourth row and the third column, but, this matrix has no third column, so this is undefined. Or you can think of this as an error. So there's no such element as a A43, so shouldn't be referring to A43. So the matrix gives you a way of letting you quickly organize, index, and access lots of data. And in case I seem to be tossing up a lot of concepts, a lot of new notation very rapidly, you don't need to memorize all this, but on the course website, where we have posted the lecture notes, we also have all of these definitions written down. So you can always refer back, either to these slides posted on the course website or to the lecture notes if you forget, like, well, A41 is that, which row, which column is that. Don't worry about memorizing everything now. You can always refer back to the written materials on the course website, use that as a reference. So that's what a matrix is. Next, let's talk about what is a vector. A vector turns out to be a special case of a matrix. A vector is a matrix that has only one column. So if you have an n by 1 matrix, then that's remember, right? N is the number of rows, and 1 here is the number of columns. So a matrix with just one column is what we call a vector. So here's an example of a vector, right? With, I guess I have n equals 4 elements here. So we also call this thing, another term for this is that this is a 4-dimensional vector. It just means that this is a vector with 4 elements, with 4 numbers in it. And just as earlier for matrices, you saw this notation like R3 by 2 to refer to 3 by 2 matrices, right? For this vector, we're going to refer this to this as a vector in the set R4. So this R4, again, just means a set of all 4-dimensional vectors. Next, let's talk about how to refer to elements of the vector. We're going to use the notation yi to refer to the ith element of the vector y. So if y is this vector, y subscript I is the ith element. So y1 is the first element, is equal to 460. Y2 is equal to the second element, right? 232. That's the first, that's the second. Y3 is equal to 315, and so on. And only y1 through y4 are defined because this is a 4-dimensional vector. Also, it turns out that there are actually 2 conventions for how to index into a vector, and here they are. Sometimes people will use 1 index and sometimes 0 index vectors. So this example on the left is a 1 index vector where the elements we write as y1, y2, y3, y4. And this example on the right is an example of a 0 index vector where we start the indexing of the elements from 0. So the elements go from y0 up to y3. And this is a little bit like the arrays of some programming languages, right, where the arrays can either be indexed starting from 1, so the first element of an array is sometimes say y1, this kind of C++ notation, I guess, and sometimes is 0 index, depending on what programming language you use. So it turns out that in most of math, the 1 index version is more common. But for a lot of machine learning applications, 0 index vectors gives us a more convenient notation. So what you should usually do is, unless otherwise specified, you should assume that we're using 1 index vectors. In fact, throughout the rest of these videos on linear algebra review, I will be using 1 index vectors. But just be aware that when we talk about machine learning applications, sometimes I'll explicitly say when we need to use 0 index vectors as well. Finally, by convention, usually when writing matrices and vectors, most people will use uppercase to refer to matrices. So when we use capital letters like A, B, C, X to refer to matrices, and usually we'll use lowercase like A, B, X, Y to refer to either numbers, just real numbers or scalars, or to vectors. But this isn't always true, but this is the more common notation where we use lowercase y to refer to vector, and we usually use uppercase to refer to a matrix. So you now know what are matrices and vectors. Next, we'll talk about some of the things you can do with them.